Okay, everybody. So I'm just going to complete the conditional statements notebook. So, oh, sorry, hang on. Where did that? Well, wait, I got to book. Okay, there we go. So we're going to complete the conditional statement notebook, and then we're going to talk about we're going to talk about how to do arithmetic in Bash. And if there's time remaining, I guess we'll do arrays, but I don't think we're going to get there today. Okay, so the conditional statements are a little funny in Bash. If you want to check some sort of condition, then you can either use the exit status of a command. That's a little bit unusual. Or you can use one of these constructs that go inside of double square brackets. Right? And so remember, we had some of these conditions that you can write that work with files. So in this case here, we've got this. This is our named shell script. So our named shell script, where you create a skeleton of a shell script file. If you remember back a couple of weeks now, the way this script works is that it would always write out to a file called temp.sh, right? And then we changed it so that it would write to a file that you specify from the command line. And now you can do some error checking. So for example, you can check if the named file already exists, right? So using -e, I can check if the first command line argument corresponds to an existing file, right? So if this is an existing file, you don't want to overwrite that file. And so we can indicate to the user of the script that this is an error, right? So we can tell them that that file already exists, right? Print the error message to standard error. So remember, greater than and to sends will send text that would normally go to standard output to standard error. And then we exit. So here we exit with a status that's not equal to 0. Right? So this indicates to the caller that, or to the shell, I guess, that the command has exited after encountering an error. And if the first command line argument is not an existing file, then we go ahead and execute the rest of the script. Right? So we write out hashtag !bin bash to the file, and then change its permission so that the user has execute permission on it. Right, so there's an example of when you might use -e to check if a file exists. All right, so that covers the file expressions that you can use. And now there's a bunch of string expressions that you can use. Right, so these are comparisons that you can do with strings. Right? So if you want to test for a non-empty string, right? So you have a string, you want to test if it's not empty, then the test for that is just $s, right? So if your variable is s, you want to check if s is not empty, right? Then it's just if square bracket $s, right? So if that's not empty, it'll print not empty, right? If it is empty, it should print empty. So if you run this script, it prints empty, right? Not surprisingly. And of course, if you change s so that it's, well, not empty, right? And then run it again, it's going to print not empty. Right? So no big deal there. If you want to test for the empty string, you can use -z. So this is basically the same thing again, right? It's effectively the equivalent test, I think. No, it's not. Sorry, it's the opposite test. So you want to test if it is the empty string, right? So here, -z tests is z not empty, right? So in this case, since s is the empty string, this should print empty. And it does. And if you change s to a non-empty string, right, it prints not empty. So again, no big surprise there. Right? Now, with strings, you can compare them for equality and lexicographical ordering. Right? So equals will both test for equality. Less than will test if the string s is less than the string t, so it comes before t. Alphabetically, Greater than will test if string s comes after the string t, right? So s greater than t tests does s come after string t lexicographically, right? So if you wanted a Java-like compare-to for strings, right? Remember, so for in Java, compare-to for strings returns 0 if the strings are equal, right? It returns, what does it return? It returns a negative value if string s comes before string t. It returns a positive value if string s comes after string t. So that script there will give you a Java-like compare-to comparison for strings if you want to, right? So here we're using equals equals. Test are the two string equal, right? Test if s1 comes before s2, right? Otherwise, s1 comes after s2, right? So you have to be careful with these less than and greater thans, right? Inside double square brackets, it's the less than and greater than they work with strings. They don't work with integer values, right? In particular, if you try to compare two integer values with less than or greater than, you'll often get the wrong answer, right? Because it's going to treat the numbers as strings, right? And then it'll compare them lexicographically. It won't compare them numerically, right? So we have some examples here, right? If you compare cat and cat, that script prints 0. They're equal, right? If you compare antelope to zebra, this should print a negative value because antelope comes before zebra, right? And if you compare tiger to poodle, you should get a positive value because tiger comes after poodle, right? Oh, that's interesting. The script, okay, so the script that's actually in your directory is a little bit different. Okay, so that's the warning right there. Right, so remember that less than and greater than, they're going to compare two things as if they were strings, right? Not as though they were numbers. So here, 100 as a string comes before 2, right? Because the 1 is less than the 2 when you compare them alphabetically, right? So that's going to print -1, saying that 100 is less than 2. And it is if you compare them as though they were strings and not numbers, right? If you want to compare numeric values, you have to do something else, all right? Okay, inside double square brackets, and only inside double square brackets, equals and equals equals, you can actually do pattern matching with them, right? So the star, the question mark, and the other square brackets where you can define a sequence, a set of characters. This also works inside double square brackets, right? So you can do pattern matching with strings as well. Again, so remember, just like though with the with the parameter substitution, the pattern matching is quite primitive here, right? Okay, so remember, star matches any sequence of characters, right, including the empty string, right? So if I want to test, does the string str, does it start with an A, right? Then I can write equals equals and then A star. Right? So A starts with an A, star, anything after it, right? And so if the string is avocado, this is going to print starts with A. Otherwise, it's not going to print start with A. Right? So if you change avocado to something else, I don't know, put an X in front, right? Run it again, it does not start with an A, right? So you get the you do get this primitive pattern matching as well. Remember, question mark matches any single character. Why is that a... Sorry. Question mark matches any single character, right? So if you want to test if a string has the sequence A followed by any character followed by an A, right? Then you can use A question mark A, right? That should print matches, right? If you change... So in this case, if you extend the length of the string, it's going to return does not match, or print does not match, right? Because Adam does not match A question mark A, right? If you delete the D, right, it's also going to print does not match, because A nothing A does not match A question mark A, right? The question mark must match a single character, right? It cannot match an empty character. All right, and then finally, square brackets. So this one's a bit of a funny one, right? So the square brackets, you can define either a set of characters or a sequence of characters, right? So here I can define the sequence of characters A through Z, right? It's inside a single square bracket, so the first character of this is any character between A and Z, right? Then the second character is any character between 0 and 9, right? Any character between A and Z, and there's 6 of these. So this will match a Canadian postal code with no space in the middle, right? And so if we run this, right? So K7L3N6, that might be a postal code, right? If you change the N to a digit, for example, it's going to say it's not a postal code. Right? 3N. All right. Okay, so you get this primitive, or you get this very simplified pattern matching as well. You also get a more sophisticated pattern matching when you use equals tilde, and we'll get to that in a second. Actually, that reminds me, we need to open up this notebook here. Okay. Now, what happens if you do want to compare integer values? All right. So if you want to compare integer values, one way to do it is to use the integer expressions that you get that the square brackets provide. So let's review those quickly. Sorry, I'm opening up another notebook, so this is going to, yeah, there we go. Sorry, I just got to quickly find the table. There we go. All right, so the integer expressions are integer something integer, right? Minus EQ is equals, minus NE not equals, minus LE less than or equals to, minus LT is less than, GE is greater than or equal to, GT is greater than, right? So if you want to, you can use these to compare integer values. Right, so this is comp int, so this is the same thing. This gives you Java-like compare to for integer values, right? So it's going to print 0 if the two values are equal. It's going to print -1 if the first number is less than the second number. It'll print 1 if the first number is greater than the second number. Here I've written it in a funny way just to show you that you can nest if statements just like you can in any other language, right? So if I1 is not equal to I2, right? And if I1 is less than I2, print -1, right? Otherwise print 1, right? So here is the if they're not equal, which means this is if they are equal, right? So if they're equal, you print 0. I1 less than I2, print -1. I1 greater than I2, print 1. Right? So if you run the script 5 and 5, that should print 0. -3 and 12 should print -1. Right? And 22 and 21 should print 1. Right? Now, you have to be careful with this too, because if you're getting your inputs from the command line, there's no guarantee that the user is giving you numbers. Right? So for example, they might give you 2 strings, right? 2 non-numeric strings. Right? So if a non-integer value is used in an integer expression, no error occurs in bash, which sucks. Right? You really want an error to happen, but it doesn't. So instead, what bash does is it treats the value as being 0, which is very strange. Right? This is very hard to debug, right? If you're not aware that this is what happens. Right? So if you try to compare hello and goodbye as 2 integer values, you surprisingly get 0. In other words, they're equal. Right? So that's not good. Right? What about A, B, C, and 3? Well, A, B, C is 0, so 0 is less than 3, so you get -1. Right? 12 and X, Y, Z? Well, X, Y, Z is 0, so 12 is greater than 0, so you get 1. Right? So be careful about that. Right? Input validation is something that you always have to worry about when you're dealing with command line arguments. Yes. This is sort of, you can kind of ignore this. I'm never going to ask you about this. So if you get a string and it doesn't really look like what you think is a number, it might be the case that it is in fact a number. It's because bash has ways of specifying integers using a different base. Right? So you can use a base between 2 and 64. The syntax is funny. Right? So for example, 2 #101 It tells bash to treat this as the binary number, so 2 is the base, right? The 1, 0, 1, those are your binary digits, right? So that's binary 5, right? So you might have a string that looks something like 2 hashtag 101, right? And you think, well, that's not really a number. It is in fact a number, right? And in fact, 5 is greater than 1, right? You're never going to get asked about this in this course, right? So don't bother memorizing that. And then there are some very unusual rules that bash uses to parse an integer value. So it is possible to get this thing to spit out an error, right? Notice up here it never spits out an error, right? When I compare hello to hello, it's perfectly happy to compare those as 2 integer values, right? If you actually go and read up on the rules that bash uses to parse integer values, you can get it to actually spit out an error message sometimes, right? Or bash will output an error message sometimes, right? So if you try to write something like 2 ABC and 1, now you get some funny error, right? And this is because bash is trying to convert ABC to a binary value, which it can't do, right? Because A, B, and C are not valid binary digits, right? Again, not going to ask you about this, right? All right, so now that we've got a way to compare numbers, we can finally test if the user has supplied the correct number of command line arguments, right? So the number of command line arguments, $at. Is that right? $at. $at's not right. Sorry, hang on. Something funny's here. That should be dollar number, dollar hashtag. I'm almost 100% sure. This is, let's see. Oh, I did it here too. Is that right? That can't be right. Well, you know what? Let's just try the script. Let's go back here. Okay. Let me try. No. I'm almost 100% sure that should be dollar number. Let's take a look. All right. Dot slash, what is this named? Okay, so it's this named shell script. So if I supply that with nothing, output, oh, well, I guess it is $at. I guess it is $amp at. I should check that. I'm not going to check it here. Let me check this. So this is saying that $at is the number of command line arguments supplied to you. Is that correct? I don't want to open up the notebook and tell me it's correct. All right, so I'm checking, is the number of command line arguments not equal to 1, right? So if it's not 1, then you get an error message, right? It requires some sort of output file name, and then exits with a different error code here, right? And so that, right. So there's that's one way to that's a way to test if you have the correct number of command line arguments. I don't remember if the assignment. I don't remember if in the assignment you have to test for that anywhere. But if you do, that's one way to do it. Right. When you're comparing the numeric values, I actually recommend you use the arithmetic. You use arithmetic evaluations instead. So let me show you that in just let me show you that in the next notebook, because I have to. There's something else I want to talk about next. All right, so that's how you write an if statement in bash, right? You can use a command or a sequence of commands, and then look at the exit status to determine whether or not the condition is true, or you can use double square brackets and then some sort of expression. Right? Most of the expressions work on files, strings, or numeric values. Okay, if you want to compare, if you want to combine combine conditional expressions, then you can do that as well. Right? So conditions can be grouped, negated, combined using the following operators. Right? So if you write a condition inside of parentheses, then that expression, then that takes precedence, right? So round brackets are like parentheses in any other language. The exclamation mark, that's negation in bash. Double ampersand is and in bash, right? So just like Java. Double vertical bar is or in bash, right? Again, just like Java. When you're using and or, so for and, if that thing, sorry, if expression 1 is false, right? Oh, sorry, I keep on forgetting, you can't do that. If expression 1 is false, right, then the second expression is never evaluated, right? So it's never evaluated, right? Because false and anything is false, right? The fact that expression 2 is never evaluated is occasionally useful, right? So in other words, expression 2 can, in expression 2, you can have some expression that relies on this being true for this to actually work, right? If that's not true, then expression 2 never runs, right? So that's occasionally useful. Expression 1 or expression 2, expression 2 is not evaluated if expression 1 is true, right? So this is the, you often see this called short circuit evaluation. This happens in Python and in Java as well, right? When you use and or in Python in both those languages, it's the same behavior. Okay, does a file not exist, right? So if you want to test if something doesn't exist, well, if you want to test if something exists, it's minus E, right? Does it not exist? Just slap the exclamation mark in front. Make sure that there's a space here, right? Because bash needs the space here and here in order to parse this correctly. Right? So if it doesn't exist, exclamation mark, space minus E. Right? You want to test if a file is readable. Is it a regular file and readable? Right? So minus F, file, is it a regular file? Right? Minus R file, is it readable? Right? Combine the two with the ampersand. Again, there has to be a space on either side of the ampersand. Right? Is a year a leap year? So this one is going to use parentheses here and here to group some expressions, right? So a year is a leap year if it's divisible by 400, right? This is using an arithmetic expression, which I haven't taught you yet, right? So if you want an arithmetic condition, write it inside of double round brackets, right? So 2 round brackets here, 2 round brackets here, then anything inside is treated as an arithmetic expression. Inside double round brackets, you can use the symbols less than, greater than, less than, equal to, greater than, or equal to. Right? Okay, so the percent sign is the same as the percent sign in Java. It computes remainder after division. Right? So is the year evenly divisible by 400? Right? So divide by 400, check if the result is equal to 0, if the remainder is 0. Right? So if the year is divisible by 400, it's a leap year. Or if these two things are true, right? So if the year is divisible by 4 but not divisible by 100, it's also a leap year, right? So is the year divisible by 4? And is the year not evenly divisible by 100? Right? Right? So there's how you use the, that's how you combine conditional expressions. All right, and now finally arithmetic. Bash only gives you integer arithmetic. On a modern computer, it's probably 64 bits. So your integer values are probably 64 bits. It's not guaranteed. You might be on a 32-bit version of Bash, right? In which case you only have 32-bit ints. The arithmetic operators, they're exactly the same as in Java or Python. And you also get star star, so that's exponentiation, right? So you can compute exponents in, or powers, integer powers in Bash as well. Right? Okay, double round brackets. So any expression inside double round brackets is treated as an arithmetic expression, right? You can assign to variables inside double round brackets if you want to, so that's legal, right? So here, I've got x equals 1 plus 2 inside double round brackets, right? So what does that do? It makes the variable x, assigns it the value 3, right? So this should print 3, and it does. Inside double round brackets, you do not need to use the $sign to dereference a variable, right? Why don't you need the $sign? Because you're inside double round brackets. It knows you're doing arithmetic, right? So it knows that whenever you write down a string, that's the name of a variable, right? So x is 1, y is 5, right? Inside double round brackets, z is x times y, so that's 5, right? When you print z, you get 5, right? No big surprise, right? If you leave off the double round brackets, bash will be very also notice that you can use spaces around the equal sign inside double round brackets. That's fine too, right? If I take everything away, bash will be very unhappy with me. Oh, now you just get x times y, right? So be careful about that, right? If you want to evaluate an arithmetic expression, make sure that it's inside double round brackets. Otherwise, bash just treats everything as a string, right? Okay. Again, notice that spacing inside double round brackets is not important, right? Spacing inside double square brackets is important, but not inside double round. Okay. Non-numeric values. So if you have a variable that stores a string, right? Missing values or empty values or unset variables, they're all treated as 0. You get no error message. Right? You get no warning, no error message. So if x is the string ABC and y is the number 5, inside double round brackets, right, that x is treated as 0. Right? So you're going to get 5 here. Here x is the empty string, but it's set. Right? So it's actually set. So there is a variable x, it's the empty string. Inside double round brackets, it gets treated as 0. Right? So again, you're going to get 5. If I unset x, so in other words, if I remove x as a variable, right, and then here try to compute something with it, x gets set to 0, right? So here you're going to get 0. Right? So if we run these, 5, 5, and 0, no error message, no warning, right? So you have to be careful about that. The exit status of the double round brackets. So believe it or not, the double round brackets are in fact a command, or treated as a command, right? And therefore they have an exit status. So if the arithmetic expression inside the round brackets is equal to 0, then the exit status gets set to 1, which is a bit odd, right? So if the thing inside the round brackets evaluates to 0, the exit status of that command is 1, so it's treated as false. Which is a bit odd, right? So 0 plus 0, right? So this gets treated as a command, right? Which means I can ask for the exit status of that command by asking for the value of question mark, right? Remember, question mark holds the exit status of the most recently executed command, right? So this is going to print 1 because the exit status of, because the expression evaluates to 0 here. Similarly here, if you evaluate anything that's, if the arithmetic expression evaluates to any non-zero value, right, then the exit status gets set to 0. Right? And so what does this mean? This means, if you want to, you can use an arithmetic expression, right, something that evaluates to an integer value as a condition if you want to. Right? Unusual, but you can probably come up with some use case for that. Right? But it would be unusual. Okay, more common is to use some sort of arithmetic comparison as the result of an expression, right? As your condition, sorry. Right? So if you want to compare numeric values, you can do so inside double round brackets using the regular or the operators that you're used to using already. Right? So exclamation mark equals, not equals, right? Equals equals for equals, greater than and less than for greater than and less than, greater than equal to and greater and less than or equal to for greater than as well, right? So if you want to check, so here I'm checking if the number of input arguments is not 1, right? So I'm validating the number of command line arguments, right? In this case, it exits. Right? If you get the wrong command line wrong number of command line arguments. Right? Here I'm testing if the number of command line arguments is at least 3, right? And so that's, if you want to test for the number of command line arguments, I normally do it inside of double round. Right? You can do it inside of double square, but then you have to use minus, in this case, minus LT to compare the two values, right? And I just think it's easier to parse that than minus LT. Right? Okay, so is even sets the exit status to 0 if the input number is even. Right? It sets it to 1 if the input number is not even. Right? Okay, so what else does it do? A missing command line argument or a non-integer argument are treated as being the value 0. Okay, so if you write dot is even dot sh and nothing, then that's going to the exit status will be 0. So it's going to assume that no input is an even number. Right. Okay, so if the number of command line arguments is not 0, right, then the number is the number that I want to test for evenness. The number that I want to test for evenness is the first command line argument. Right. So divide the number by 2. Look at the remainder. If the remainder is not 0, it's odd, right? So we exit with 1. Otherwise, notice there's no exit statement. So a script that has no exit statement always exits with 0. Right? So in other words, if this if statement never runs, then the script ends and you get an exit status of 0. Right? So is 2 even? The answer is yes. Right? Is 3 even? The answer is no. Right? So the exit status is telling you whether or not the number is even or not. With checking for evenness and oddness, a lot of people will write this as, what's the wrong way to write this? A lot of people will write if val %2 is equal to 1, then exit with 1. Right? That doesn't work. Right? So in other words, you're going to test if dividing by a number and then looking at the remainder is 1. Right? That only works if the input values are positive. Right? So whenever you're testing for evenness or oddness, you want to check if the number, if after dividing by 2 it's not 0. Right? You don't want to check for 1. Right? So check if it's not 0. Okay. Random numbers. So it's a little bit unusual to generate random numbers in Bash because that's not really what the scripting language is designed for, right? But you can, if you need to, generate a random number, right? So the easiest way to do so is to use this variable called random, right? In all caps, right? So built into Bash is this variable called random. Every time you look at the value of random, Bash assigns that variable a random value, right? Between 0 and 32,767. So that's 2 to the, 16 or 2 to the 32 or something like that, right? Minus 1, right? So every time you look at the value of it, it gets set to a new random value. So this script is going to use some arithmetic to print out a random number between those two values if the script has no command line arguments given to it. Right? If you give it one command line argument, then it assumes the command line argument is an integer value equal to n, and it prints out a random number between 0 and n minus 1. Right? If one command line argument is given. Right? If two command line arguments are given, sorry, I screwed up the markdown. Oh, that's because of that $sign. There we go. Oh, still messed up. Star, oh, n, that should be a star. Okay. There we go. So if you give it two command line arguments, m and n, then it prints out a random number between m and n minus 1. Okay. All right, so if the number of our input arguments is greater than 2, we print out an error message. Right? Alternatively, you could just choose to ignore everything, the third, fourth, and fifth command line arguments. Right? In this case, I'm calling that an error. Oh yeah, see, I thought it was dollar hashtag. Huh. All right, I'm gonna have to go back and double check those scripts, sorry. Okay, if the number of command line arguments is equal to 0, right, then print out a random number between 0 and 32,767. So I'm just gonna look at the value of random and print that out, right? If the number of command line arguments is equal to 1, then I want a random number between 0 and the value of that command line argument, right? So I'm going to assume that that's an integer value and it's positive, right? So I'm just going to take random and divide it by your input value and then take the remainder, right? And that gives you a value between 0 and the input value, minus 1, right? Now, to get a value between m and n, minus 1, right, where m and n are your two inputs, right, then the trick is, right, compute the difference between m and n, right, so subtract the two values, right, take your random number, divide by the difference, and compute the remainder, right, so that gives you a value between, so n minus m, that's the range of values, right, so I'm going to compute a random number between 0 and the range minus 1, right, and then I'm going to add back the first argument. So now you have a random number between m, right, and n minus 1. And so that's the trick to generate a random number between two specified values. Right, and if you try it out, everything works just fine. Right, so here is random number between 0 and 10, not including 10. Right, here's a random number between 30 and 40, not including 40. Right, there you go. All right. And so that's arithmetic in Bash. The operators are all the same as in Java, and you also get star star if you need to compute an exponent, right? Which I guess is what you do in Python. Sorry. I'm actually not sure how overflow is handled. So I think what happens is overflow just wraps around like in any other language, like in Java. I guess we can test it out here. 60. Well, no, it's going to be a huge number. So I'm not sure how overflow is handled. But arithmetic is not Bash's strong point, right? It's not really what the language is intended to do, right? Mostly it's a string handling and file handling language. All right, I guess there is some time left. So I guess we'll start the regular expression notebook. Okay, so start with a quote. Okay, some people when confronted with a problem think, I know, I'll use a regular expression. Now you have two problems. All right, so what's a regular expression? So a regular expression, or regex, so that's what you'll normally see it called. That's another name for it. It's a sequence of characters that specifies a pattern. Right, now we've got star, question mark, and the square brackets, right? That's the pattern matching that we've been doing so far. Regular expressions are much more powerful in their ability to express a pattern. So regular expressions are different than Bash's built-in pattern matching. Now, the really, really confusing part is that the regular expressions also use star, question mark, and the square brackets. So you always have to be aware of the context of your program in order to determine whether or not you're using a regular expression or if you're using Bash's built-in pattern matching. Right? So that's the first thing you have to watch out for. Okay, so regular expressions actually come from formal computer science. So this is old school, hardcore computer science is where these ideas come from, right? This is when people were interested in studying what is a computer language, right? And how do you formally specify a language, right? So this is where all the ideas come from. In, I guess, most modern undergraduate curriculums, you don't see very much of that anymore, although you will see some of it eventually. If you ever take the compilers course, you're going to see a lot of it, but that's not until 4th year. Okay, now regular expressions are quite complicated, so I'm not going to try to tell you everything there is to know about them. So what you need to know is what's in this notebook. All right, and so you don't. If you want to, I think there are some links on at the bottom of the page. Yes. So if you want to know more about them, there's lots and lots of resources about finding out, about explaining what regular expressions are and and things that go beyond what's in this notebook. Right? All right, so when you're comparing two strings, you can use equals or equals equals, right? When you do that, you can also compare them. If you're using double square brackets, you can use bashes but built-in pattern matching. Right? There's a third operator. So it's equals tilde, right? No space between the equals and the tilde, right? Otherwise, you end up with tilde expansion. Right? So equals tilde performs what's called regular expression pattern matching. Only inside of double square brackets, though. Right? Okay, so here's how you would use it. You've got some string. You want to check, does it match that pattern stored in the variable RE, right? So if it matches that pattern, then this one it prints string matches. The string matches that regular expression. Otherwise, it prints the string does not match that regular expression. Okay, yellow box. So this is a warning. When you in the notebooks, this is trying to warn you of something, right? Remember, I told you inside double square brackets, there's no word splitting. So usually you don't quote your variables, right? If you quote the regular expression, so if you quote this thing RE, right, then quoting the variable expansion forces the entire pattern to be matched as a string instead of performing regular expression matching, right? So if you quote that thing there, quoting the variable expansion, yeah. So if you quote that thing there, bash is just going to do regular string equality, right? Quoting part of the regular expression forces the quoted part to be matched as a string, right? So if you quote part of your regular expression, then that part of the regular expression gets matched exactly as a string and not as a regular expression, right? So you almost never quote a regular expression, right? Again, this is very confusing, right? You'll write your regular expression, you'll spend hours trying to debug it, and then only later on you realize that, oh, it's not working because I quoted it, right? And that's no fun. Okay, so this notebook, let me just show you an example of a simple regular expression, of some simple regular expressions, and then we'll call it a day, and then come back and do the more complicated ones. All right, so the way the script works is that that's the string. The second argument is the regular expression. So if your regular expression is just a plain old string, then there is no regular expression, right? It's just going to do pure string equality, right? So is hello equal to A? Obviously, the answer is no, it's not, right? So the string hello is not matched by the regular expression A, right? Is Warworth equal to A? The answer is no. Oh, wait, what happened? Line 12. Sorry. Line 12. Oh, that's fine. Oh, echo. I must have accidentally edited this at some point. All right, there we go. The string Walrus is matched by the regular expression A. Well, that's weird. Oh, yeah. Sorry, I misspoke. I'm sorry. Okay. String equals tilde A. So the A is a regular expression. In this case, it means, is there an A in that string? Right? So is there an A in that string? Right? That's what that regular expression means. Right? So is there an A in the string hello? The answer is no. Is there an A in the string worse? The answer is yes. So it prints out that the string is matched by the regular expression A. Right? Okay, so here I've got a regular expression and. Right? So this is basically asking, does that string contain a substring equal to and? Right? So there is no and in hangry, but there is an and in Sandman. right? So number one, that's the first thing you have to watch out for when you use a regular expression, right? When you use something that just looks like a regular string, that pattern can appear anywhere in the matched string, right? And now normally that's not what you want. Well, often that's not what you want. Often you want to know, does it start with something or does it end with something or something like that, right? And so then you're going to need an anchor. But I think we'll talk about that next class. So that's going to be next week. And so I guess we'll end it there. Anybody have any questions about the assignment or anything else that's going on? No? All right. Does anybody need me tomorrow during office hours? Anybody? All right. So I might end up canceling office hours for tomorrow so that I can go do some of the reconciliation day things. All right. So I'll post a message on OnQ.